Hello, and welcome to the Earth Podcast. I'm your host, Jason Adams. Today, I'm joined by two of the leading sources in understanding data and how artificial intelligence is changing our landscape. Kyle Murphy is the Director of Science and Architecture for Earth. Previously, he was the CEO of DigTix and the Chief Product Officer for 4IQ Solutions. And we're also being joined today by Zank Bennett. Zank is the CEO of Bennett Data Science. Thanks for joining, guys. I want to start with Zank. Why don't you tell us a little bit about yourself and how you ended up in the data science field?
Sure. Yeah, no problem, Jason. So let's see. A long time ago, I was in college and I was trying to figure out what to do. I was quite good in medicine and had quite a big interest there. And I was an engineering mind, always have had one. And a professor, I was walking him to his car, as cliche as it could be, carrying his bag for him. And he said, "Why don't you go into biomedical engineering?" And I did, and I did quite well there. And then in graduate school, I studied uh, computer science and electrical and computer engineering. And so with those two degrees, I went off and did a bunch of different things with that. I worked in audiology for a little bit, and then did some work with a big consulting firm for about 10 years. And then shortly thereafter, I founded Bennett Data Science. And I guess from a high level, we've helped companies from retail all the way to helping people sleep better at night. And generally, the way I look at what we do is companies create a lot of data in their day-to-day operations. We look at that data and see, we look for ways to help companies do what they do just a little bit better, more efficiently. Working with Kyle over the last few years has been a real pleasure, but he understands the product side of things. And so I consider myself and my firm to be very product driven. And so working with Kyle, we've been able to really dive into the products that we're probably going to talk quite a bit about today and really help Kyle to build products that helps the customers understand risk and reduce incidents. We'll talk a lot about that. And so, yeah, I guess the lead up to where I am now was how do we look at all of the data that we have access to help companies reduce the incidents that cause damage and cause it could be damage to infrastructure, it could be someone being hurt. So this work is very important. In this case, the product is risk, and we take that very seriously. And so it's a lot of fun for us as a team to look at how we can do that better and pull more data sources in and make our algorithms better, because at the end of the day, we're supporting a really cool product, right? We're making things safer.
Nice. That's great. Kyle, why don't you tell us a little bit about yourself?
Yeah, and thanks for having us on here, Jason. My name's Kyle Murphy. I got my bachelor's degree in computer engineering from the University of Cincinnati, and it was focused more on the software side, although I did get into some of the hardware as well. After that, I worked for a couple different startups. One of which we kind of started to dabble in AI a little bit. And then I started my own company, DigTix. And over the next, I would say, 5 to 7 years, we were collecting a lot of data through all sorts of, just through the normal course of business and doing SaaS-based cloud offerings. And at a certain point, it was in 2019, we kind of thought, well, what can we do with this data? And what do we need to make predictions that will help make our industry and the public more safe? And so that's when I got an introduction to Zank through actually the person who people I worked with at one of the former startups on AI introduced me to Zank. And it was a really great match. We started diving into the data that we had, and we kind of ran. It was very much kind of a proof of concept, just to see what we could do with a little bit of effort, and it came out uh, beyond what I could ever imagine. The results were, and from there we kind of said, well, if we can do this much with a little bit of effort, what can we do if we throw everything we have behind it? And since that was 2020, right around when the global pandemic was taking place, and we since then we've emerged as, I think, the best uh, risk predictions is in our industry. And I look forward to, we have a lot of great ideas and places that we can go from here. And so I'm really excited to see what we can do with that, with all of the data that we have.
Yeah, that's great. I tell you, sometimes we get so excited about some of the things that we've seen occur out of this process. It's really kind of revolutionizing what we're doing in our space. Sometimes I think we got to get back to the basics and figure out how AI works and understand that, because a lot of our clients are unaware of the possibilities that you can do with data. So, I'm going to start with some pretty, I think, generic questions, but I think that are incredibly important to understand how risk works. So, Zank, I kind of want to start with you. And I think one of the things that I found interesting in my journey to learn more about this was just trying to figure out the simple mechanics of the whole solution and how the idea of AI works. So can you kind of explain in simple terms how AI identifies and solves like kind of complex problems, particularly in relation to like patterns and predictive analysis?
Sure. Yeah, this is important stuff. So we start with a training set. Yeah, and in a training set, we're teaching an algorithm to recognize patterns. That's really what it is. And so we've got some patterns of yes, there was an incident, and some patterns of no, there wasn't. And so there's a whole bunch of data leading up to, if you think about it in a spreadsheet, if you like that, and I tend to like that sort of idea here, you've got a whole bunch of columns describing the site where something's taking place, and in the very last column we'll say, was there a 1 or a 0? And that's just a classification algorithm is what we're talking about here building. And in that last column, the 1 or a 0 means yes, there was an incident, or no, there wasn't, and doesn't have any indication yet of what the cost was or any idea of the magnitude of that incident. Just to keep it at the simplest terms, you have a 1 or a 0 in that last column. And so now imagine a bunch of rows, like a whole bunch of rows. Now imagine millions of rows. And so what we do is we build a classifier by first creating a training data set with, say, 70 or 80% of that data, and then holding the 20% out. And in that 70% of the data, we pass it to an algorithm that learns how to predict that last column for us. And then in the test set, we call it, or validation set, we will give the algorithm all of the data in those columns leading up to the 1 or the 0, but we'll hold back the 1 or the 0. And we'll say, what do you think? And the algorithm will tell us what it thinks. And maybe it gets 30% right and 70% wrong. And you could say there's some accuracy score there. So I'm not going to get too into the intricacies of scoring and how we assess models and how they perform. But I will say this. There is a really big elephant in the room. And that is that, thankfully, there aren't many incidents. So for every time there's a ticket, there's not always an incident. As a data scientist, we'd love to see it balanced about 50-50. As a company owner, that would be, that would be untenable, to say the least. So with the data that we're seeing, the reason that this is such, what do I say? It's so significant what we've done and the accuracy levels we are able to achieve. It's so significant because there are so few incidences. So if you look in that last column, you have to really look for a 1. It's just a whole lot of zeros.
Gotcha.
So at the basic, most basic level, we've got a training data where 70 or 80% of data is thrown in with answers to an algorithm, very specifically formatted. Then we look at the test set on the way out and said, how did you do predicting when there was going to be an incident? And that's what we got really, really good at. And it wasn't that easy because we didn't have a lot of incidences, and we never do.
That's interesting. As you say that, I guess this next kind of brings me a question to Kyle. You're fortunate, Kyle, that working at Earth, it would appear that you have access to a lot of data. Can you kind of tell me about how having those data requirements and the processing requirements are actually better suited for these large data pools, and having more data has value? Can you kind of go into that a bit for us?
Oh yeah, absolutely. Most of the time, more data is better, right? That's assuming, of course, that the data is quality. That's paramount and critical. But to kind of echo what Zank said, it's really pattern recognition, and it's pattern recognition that's backed by advanced statistics and probability, right? And so when you look at millions or tens or hundreds of millions of excavation jobs or anything for that matter. What we're trying to do is we're trying to predict 1 in 1,000. So we have it's on the order of 1 in 1,000 excavation jobs result in an incident. Some people call this anomaly detection, and I think that's a pretty good word for it. But it illustrates how difficult it is to say, imagine you have 1,000 jobs and you have to pick the one out of those 1,000 that's going to result in an incident. That's a really tough thing to do as a human. It's not easy for computers to do it either. But given the large amount of quality data, high quality data, that allows us to use these data science methods and principles, again, backed by probability and statistics to recognize these patterns.
That's interesting. I think it brings us right back to Zank. I hear what you're saying about the algorithm and really trying to optimize that. My guess is you probably have to look at multiple algorithms, right, to look at all of this data. How do you make the determination? Is it just stats based, or how do you determine which algorithm best suits the challenge you're facing?
Yeah, this one. Yeah, let's get into this. And I want to say before I start that we have an obligation to do this. Like I feel literally obliged because people can get hurt. And so we look at increasing model performance as, again, almost a duty here, right? It's very, very important to us. So we go all the way back to what the objective function is, right? What is, and the objective function makes sense. You might say that in a meeting to say, what's our objective here? And let's, have some functions that lead towards that objective. In AI, that's actually mathematically defined. And so what is it that we're trying to minimize, right? We're trying to minimize the number of times we make an error. And so we look at false positives, false negatives, and we come out with a trade-off between the two. And this is a conversation we had early on with Kyle, is how do we convey this to our customers? How do we say, yeah, this is going to result in an incident or this isn't, when there is this cloud of probability around the answer? And so as we incorporate more data sources, as Kyle said, more good data sources, that's very, very powerful. And then we start with the objective function. We have a way of measuring that objective function. That's generally the second step. And then we try algorithms to see how they perform based on that yardstick, right? Based on what did I just say? Based on the objective function leads to a metric, a quality metric. And then we try new algorithms, we employ new algorithms until that metric is the maximum it can be against all the different algorithms we can bring to bear on the problem. And this is ongoing for us this year. In fact, we just kicked off a new effort this quarter to bring increases to our accuracy. And I think, for our current clients, maybe it's a bit of a spoiler, but we will get more accurate this year. We're spending quite a bit more time, and we do have more resources now to bring more data to bear on the problem. So algorithmically, we will get better. And then in terms of more high quality data, there's also more to bring to bear on this problem.
Nice. That's very interesting. Kyle, as Zank kind of talks about that, one of the things that strikes me is what's the magic that happens behind the scene, and how can a client actually feel that the algorithms that we're using will be predictive and solve his problems? What level of transparency is there when you're looking at all this data? How can you be assured that you're really making good decisions and it's not just a random guess?
Yeah, sure. So a couple things. The first is what we refer to as interpretability. And that's the idea that when you get a prediction, you have some idea um, as to what went into that prediction. And that's something that's interesting in the AI field. In fact, some uh, a lot of AI, they actually are required, at least at an industry perspective, they're required to provide interpretability When you're talking about things like insurance, predicting, maybe who's going to end up in the hospital in the next year versus not. When they make those kind of predictions, sometimes they're bound by law to provide
Mhm.
interpretability. So you'd have to disclose those risk factors and ensure that none of those risk factors are even, discriminatory or things like that, right? And so that's, we have these interpretability models that we actually just introduced pretty recently in the second half of last year, 2023, where it provides you, it's not just a black box, right? You're not just getting some random prediction. You can see why. And you can even start a little bit to understand the patterns the explain the explainability factors behind those predictions.
Nice. It strikes me, Zank, you've been doing this for some time, probably more than most common people are kind of aware of things like Chat GBT and that. I think you were ahead of the curve, and so what a great place to be, both from I guess, a science standpoint, but also from a business standpoint. I'm kind of curious, is like, what are the biggest challenges, like when you're doing this, and like, what are the limitations, like when you're training these models and when you run into these super complex problems, how do you face those? How do you address it? What are the challenges that you face at the highest level of dealing with these challenges?
Yeah, this was really a tough problem. 1 out of 1,000 being a positive, resulting in some sort of an incident, that is really truly a challenge. And so I think the hardest part is all in the very beginning. I always say, if you define the finish line that you're going to run through, when the starting gun goes off, you know exactly where to go. And so as long as we define the beginning correctly, and Kyle will tell you, this was not easy in the very beginning. He came to us and said, "Hey, we've got this data." We said, "Where are the positive incidences?" And he said, "They're there. So there are so few. There's got to be more." And so what we do is we look at that and we say, well, if we've got to do this, we've got to define our objective function very, very carefully, because you can easily get lost. Everything starts to look like noise when you don't have many examples like that. And so we did some tricks like oversampling of the ones that were positive results and undersampling of all of the tickets that resulted in no incident. So we used techniques like that. And then, especially in industries that are well established, such as the energy, industry, there is a mountain to climb to convince people that this magic we're doing is real.
Mm.
And I've had a job before where I was affectionately called the wizard. And I thought it was fantastic in the beginning. I was such a dear friend who called me that. And I started to believe that it wasn't so fantastic after a while, because we don't just wave wands here. I mean, there's math behind all this, and we can stand on it. And we do. And as Kyle mentioned, interpretability really matters. And so we don't use black box models. And this doesn't go against what I said moments ago when I said we'll do anything to get more accurate because it really matters, and health and safety are here. We use what I call clear box methods, where we can look right in and see what's going on. Well, at least we can if we're trained in this sort of thing. But these methods allow us to extract what we in the field call variable importances. In other words, if we put a variable in, how important is that to the outcome we're predicting? Those are called variable importances. It's one of the few things that's named really well in our field. And so we look at those variable importances and we report them back out. And that doesn't mean in parallel we can't use like a deep learning model that could have higher accuracy, right? And help us, and we can blend models. But we always run in tandem, at least in tandem, so that we have something to say, this is why we made the decision we made, to help Kyle in the beginning anyway, and there's a lot more people involved now. But, and Jason, even on your side, reaching out to people who are talking to customers every day and saying, this works, and here's why it works. Look what we can show you. And I hope, Jason, that, during this talk, we talk a little bit about getting that data back to our customers and how important that can be to not just tell them a story, but to show them a story they never thought that never even thought about. And Kyle just spoke at our conference. Was a few months ago, Kyle, and you gave a little quiz. You said, "Hey, what do you think about this? Or do you think this is important and this is important?" And it turns out that not a lot of hands go up when you say, "Do you think this is associated with risk?" And we can prove that it is, but most people wouldn't think that it is. So that's really fun, is showing some counterintuitive facts backed up by data that tell a story that people weren't really aware of. And to me, that's one word for that, and that word is value.
Absolutely. I can't echo that anymore. I've been doing our industry for around 30 years now. And so we have what we all believe is our gut can tell us the right thing, right? We look at something, we go, I know that because I've seen it 100 times. And when Kyle did his presentation and went over some of the factors that would not seem to be really relative to whether there would be an incident or not, and then define that maybe the most relevant of those issues was something that wasn't even programmed in my own gut, was very surprising to me. And I think it's that sometimes you get so deep into a process and so entrenched in the day-to-day that you never added that type of data into your thought process. Thus, you don't take that into consideration. What's nice, I think, about AI is it thrives on bringing more and more data in and learning more and more. Whereas a general human being, I have only limited capacity, right? And so I go with what I know, and I'm really not going to shift my view unless I see something significant occur. Unfortunately, in our industry, significant can be loss of life, and none of us want to explore that. We don't want that to happen. So What's really compelling, and you said this early on in the process, is how we can take our clients' data, bring that into our model, and get more precise for them. And I find that to be probably the next step, because it seems currently we offer solutions that speak broadly on, here is the American model. This is what we see happening in North America. But what we haven't really gotten to the point yet is saying, this is what broadly happens for where your facility lines are specifically and only around yours. So you're not taking outside data that is not relevant and using that to really skew the end result. So as a human, I can't process that much data. And so I find this really incredible. The one thing that kind of scares me, though, and I've heard Kyle talk about this, and I want Kyle to kind of follow up on this for me, is the models are great. But with every model, when you do something and you have an action, you're now changing that data, right? Because I'm doing something because of what the model's telling me. So it would seem to me my results are different the longer I run that model. How do you address kind of that change that occurs through that process?
Yeah, so and that's a great point. And really, what it comes down to is the game isn't the same everywhere. If you think of it as a game, which it's kind of fun to do that. Seasonality is a huge factor, right? Places like Texas have a completely different climate than, say, New England. And then on the utility side, gas gets damaged. Underground gas gets damaged differently than underground fiber, right? And so that's why having more targeted data can lead to better predictions. But when it comes to intervening, what we refer to as intervening, let's say you get a prediction and it says that, hey, this excavation has a relatively high probability for an incident. Well, hopefully you intervene on that to prevent that incident from occurring. That by itself changes the game a little bit. If you do that consistently, if you start intervening consistently into these high probability risks, it's after a while, things, you've changed your baseline. And so you need to consistently stay on top of that. The word that we use for that in the AI space is drift. I think it's a great word. It's a really cool word, and it's basically just that. It's the changing of things over time. Now, let's say you don't do anything at all. 10 years from now, your predictions are still going to be, I would guess, significantly less relevant than they are today. So it's not something that you can stop. We live in a very, an ever-changing world. And so if you just kind of sit on your hands and do nothing, with these predictions, you're still going to experience drift. It's just a matter of how fast you're going to experience that. And so the way you do that is you have to constantly consider events, not just in the past, but also events that are happening yesterday, today, events that will happen tomorrow, in the coming year, and so on. And only through that are you going to continue to get value out of all of the things that we're discussing today in AI.
Yeah, that's really interesting. I think one of the challenges, it's as you look, the world is becoming more aware of how valuable data is, right? And so now we're putting better systems in place to capture better data. Using your example, Kyle, if I had all this same data 20 years ago and I ran the model and I was told this is more than likely an incident, just applying that same model to my data today probably would not give me the same results. There's too many other factors that have passed throughout that time. The other thing I wanted to hit on, and I think this is really important, especially for people that are using risk as a tool to help reduce damages, you use the word intervene. Sometimes intervention can take many different roles, right? It can come in the role of simply just a notification, right? You just send a message out to say, hey, we've identified a riskier area, please be aware. But it also can take place of somebody rolling a truck out somewhere and being a little extra cautious while it's out there. We've got clients currently that use this simply as an additional layer of information to be passed on along with the ticket. I really love that. But one of the things that I kind of sit back and think to myself is, this is so powerful, our risk tool. And I've been doing this for a very long time. This is as powerful, if not more powerful, than the introduction of GIS was into our world. That changed the name of the game in many ways because we went from a text-based solution to integrating real-time spatial data, which is what we're really trying to protect, stuff in the ground, stuff in space. But what it's interesting to me now is we've got this great model, and of course it works great in our products, but can you use this data and this kind of theory and algorithms in other applications, whether it be, other ticket management systems or anything else? What are your thoughts on that, Zank?
Sure. I mean, we're currently working on a damage model. I don't think that's any big secret, where we really want to let our partners know when there's going to be damage and what that damage might cost. Just imagine that. And Jason, you brought something up that I haven't addressed, and I think it's a really important. And I'll just tell like a bathroom scale story about this. If we look back at what's happened in the past, that's descriptive analytics, and those are dashboards. We've all seen that. You can say, maybe I walk up to the scale and it said, hey, you weighed 175 pounds yesterday, or maybe last week your average was 175. That's just descriptive. It's not smart in any way. It's nice. And then there's predictive, right? Which is what we've been talking about risk. And so I might walk up to the scale and it might, beep as I walk in because it knows I'm coming in. This is getting strange. And then it says, hey, Zank, you're about to weigh 176. Sweet. I step on it. I've been eating a lot and working out or whatever it is. And sure enough, the scale's close or it's right. And that's predictive, and that's fantastic. And that's what we're doing with risk. And it can even tell me why. It can say, well, I've been tracking your food as well from the app that you're using. And I know how much you ran from your pedometer, whatever it is. And then there's the third case, which is prescriptive. And this is really cool. So then I walk in the room and the scale says, hey, you're about to weigh 176. You want to weigh 177? Here's what you need to do. And this is the really beautiful stuff. And that's what Kyle was getting into a little bit. As things change, as companies respond to what we're offering, we can learn based on what companies are doing to mitigate risk and see lower and lower risk. And our viewpoint of having data all around the US, North America, that viewpoint gives us such an advantage in that space because we can see how companies change over time. And we can say, this is really working. And so getting into prescriptive is huge. And the damage model is just part of it, being able to say, here's what your damage is going to be. And here's what it would be if you intervene. And is it worth it? And, we do all this based on probability. It's not going to be every single time, and it's not going to be never. It's going to be often if we say it's got a high probability. and putting that probability cloud around these incidences and offering up that idea of damage is really, really powerful. We're also doing something else is we're training as often as we need to make sure our models are as accurate and as representative of recent history as they can be. That could mean training every hour, every day, more than once a week for sure. And so we've got all the architecture in place to train as often as we need to make sure that when a company, one of our partners, has an incident, something happens, they can rest assured that we've learned from that, and tomorrow we will be representing what happened in our new predictions.
Nice. It seems to me that there's a lot of investment behind building great models. So I have to make the assumption that the ROI for clients is very definable. So the challenge becomes now is how does a client help themselves get more accurate data? Thus, they can then get more accurate prediction, which hopefully will help them reduce their challenges that they face moving forward. So, Kyle, as we start to continue to grow more data, we start to do this, how can clients really take advantage of the work that you're doing today? I know Zank kind of leaned in a little earlier and said, look, we're going to become more accurate. And I love the confidence. But how do we get there? And how does that mean value for our clients?
Sure. And there's one thing just to kind of tie it in. I see an opportunity to tie some things together here, which is really nice, which is explainability kind of, it lends itself to prescriptive predictions, right? Prescriptive AI. And so when you see, a high risk ticket, and you see that, for example, one of the reasons it's high risk is because Acme Excavation it is just notoriously bad on Fridays, especially Friday afternoons, right? Then you're going to say, well, what can I do to get them to not dig on Friday afternoon, right? Even if it means kind of gaming the system, or just reaching out to them and saying this, or intervening some way. So explainability is one of the major factors I think that leads to prescriptive prescriptive AI and actually reducing those damages by effectively and intelligently intervening. And so that's the first thing that they can do is they can, pay attention to the data, right? Don't just let it sit there and do nothing about it. And we're getting to the point now where we can more intelligently suggest intervention strategies and things like that. And they range from anywhere from, as you mentioned, just sending out a notification to someone, even if it's just via email, or maybe it's a phone call, something very cheap that can be very effective. Or doing something a little more, involved, like going on site and visiting them, for example. So that's the way that I can think of is to really care about the data, care about collecting quality data within your applications or your processes, and then using the data that AI provides to make those intelligent decisions moving forward.
Yeah, that's really interesting. I think one of the things to begin this process, and we talked about it very early, was how we look at incidents, right? So sometimes we call them damages, but what we're really saying is, was there a particular thing that was negative that occurred because of the ticket, right? That happened. But one of the challenges is we don't really have a great industry kind of database of where all of these incidents are. And if we do have the incidents, we don't typically have a lot of supporting additional information to tie it to the incident. But what it does seem is that our clients can track that information. And as Zank was alluding to earlier, we can start to build the models to be very specific using their incidents and their information. But we could also populate it with other stuff. But it would seem to me that if we had an industry standard database, something like DIRT, but that's more active, that's really available in real time, we could do some amazing predictions. So I'm kind of curious, Zank, in your experience, kind of outside of damage prevention, what we're kind of talking about today, have you seen other industries adapt kind of to finding ways to gather that data to use it on a large scale, or is this usually left to the individual to try to gather that themselves? How does that typically go?
Yeah, boy, what a great question. I mean, there's so much in that question, and it really hits me because we spend most of our time cleaning data. And I thought that was one of the things you were going to get into, Jason, was, you've got all these data sources and we put them all together. And I think we're all smiling because, behind the scenes and the cameras we have on right now, we're working on helping more of our customers to bring their data in and build these models. And so there has to be some sort of formatting, some centralized formatting, some standard. And wow, I would love it if data were more standardized across all fields. In terms of how we generally get more good data, again, I studied a lot of physics in my university days, and so I tend to think in big extremes. If we could just have a column that says there's going to be an incident, then we'd always know. And I know that sounds insane, but it tells me that the goal line is 100%, probability of predicting an incident is 100%. We're just going to nail it every time.
Mhm.
And if we don't have anything that's even remotely correlated to it, then we've got zero. And I always start my mental conversations with myself in that way. And I say, what would lead us? What's the closest thing we can get to a column that just says, is there going to be an incident? And I know I'm making it up. And so what are those data points and what do they look like? So from the very beginning, when we do some very initial data analysis, we look at things like correlations to those incidences, and we use techniques from anomaly detection that Kyle mentioned earlier, and we start to look at things that are correlated and things where we find signal, as we say. And this is going to bring me back around to something I really wanted to say, and I'm glad I have the opportunity. And Jason, you and I were talking about it moments ago. There are certain things that we bring to bear on problems, and then we come out with these insights. And then Kyle went, and spoke about them and said, "Hey, I bet you didn't know this." Well, I want to be an ally to all the people who have been involved in this industry for decades. They're always right. We add to it.
Uh-huh.
It's not that we're coming out and telling you a perpendicular story.
Right.
It's simply not like that at all. And one of the things I've learned over the years from being a very product driven, AI practitioner is to talk to the people doing the work initially and say, where is the gold here?
Right.
And Jason, that's where we find the right data. And we say, well, if that's what you think is indicative, right? There's a whole book on this called Blink, right? It's people who are so professional, so good at what they do. They can hold the surfboard. This is for me. They can hold the surfboard on the sides and say, that's a good board. I could ride that. How in the world would you know? You haven't looked at the measurements, nothing. You just hold it, you feel it, and in 1 second, you know.
Right.
And we need to work with subject matter experts in the very beginning to say, what's important to you? And then it's a beautiful aha when they say, well, we're not collecting that, or we could collect more of that. But that's always where we start. And then we use our intuition and look, this is an art, right? I mean, it's really hard to answer some of these questions. How do you know what you don't know? And that's where you need seniority and intuitive data scientists and researchers to say, well, there's a story here, but we need more. We need to, expand our color palette. And I think these data points might do it. Weather is a really, really important data point for us. Geospatial, there's all sorts of stuff that might not be in the ticket that could be really important. So I'll leave it at that.
Sorry, that's one thing we need to touch on is how easy this is, right?
So
That's
easy.
yeah, I mean, that's one of our that's a significant value prop in my opinion. You don't have to you can submit your data, right? And we can build a bespoke model, but you could you could sign up and use it today. Like there's nothing stopping you from getting predictions today. Um,
Yep.
Super easy, super easy, and it's and now our predictions are coming back in less than a second.
Nice. The one thing that's interesting as you say that, Kyle, is inside of our products, we've always had almost predictive analysis, basically just by using filters, right? We see commonalities. We know that if a certain excavator damaged us, we can record that. And now we've got a history of that. And so using that data influences AI. But really, realistically speaking, that was the first steps of AI. When you started to say, I see this thing occur, and when that happens, I need to do something about it. But being a human being, I can't ingest the amount of data that comes into the system. Just at Earth alone, we're receiving more than 70% of all the tickets in the entire industry. We're talking hundreds of millions of data points. Hundreds of millions of tickets, let alone the 50 to 70 fields of data on every ticket. So when you start to look at that, you're in the billions, hundreds of billions of data points that we can use to identify this. So as we start to move forward, one of the things that I find very interesting is we're using it to predict risk now, which is great. And also I think it has a lot of value for clients. But I'm curious what else you think we might be able to do with this. What else predicted could we do? What else can AI help our clients with in the future?
Yeah, I mean, there's really no limit. There's no ceiling. You talk about risk, and we focus a lot on incident likelihood. We are also predicting incident impact. So, in other words, if an incident does occur, are we talking a small impact, or are we talking something significant? And that has impact to reputation, as well as financially. Um, and you can save or lose so much money when it comes to these incidents and preventing them. And so it's not a small game that we're playing. It's quite big. And then you get into other things like, how much will it cost to intervene on this, or prevent an incident from occurring? You can look at things like resource planning. How much resources do I need to deal with the influx of tickets, whether it's a yearly basis, or some law goes into effect that is going to change things up a bit. You can predict. I mean, I could go on. I'd like to hear what Zank might have to say in terms of what we can predict with the data we have.
Yeah, there's a real fun one that comes up in my mind, and that we talked about this a while back, and this may find its way onto our roadmap this year, is educational programs. And it's not that difficult to think that we could quantify someone's expertise, and how that relates to handling a certain excavation or a certain site. So that's something that could be quite powerful, and we have some data on that already. And then what about fine tuning a large language model? And that's something that we're currently looking into as well. Can we converse, through a model that has all of this, data that we've been talking about, and converse with someone and say, hey, that this is likely going to result in an incident, and then talk about why, and talk about, steps to make sure that doesn't happen. Those are all, really cool, ways to leverage the latest technology. And these large language models that have come out in the last couple of years have made it possible for us to take that model explainability, and then really put that into something that someone can almost converse with, and not even almost anymore. You can actually converse with a model that's telling you where the incident might occur. So these are just a couple areas, and yeah, I mean the cost modeling will be a lot of fun to do. I just smile, because giving all this information back to practitioners, and companies, partners, it's so powerful, and it's such a good use of our time to put that data and that power into the hands of the people who can really do something about it.
Yeah, Zank, I'm glad you hit on the point. I have to tell you, one of the interesting kind of challenges that we faced was, now we've got this great model, but how do we see that predictive data and then use it to make our staff better prepared to face these challenges? So it's nice in our world, we could actually integrate our platform for training and certification, Coursera, and allow it to, when an incident is occur, we can actually send a notification out to the person that's working in the area. And if they don't have proper training on that type of incident, we could actually pre-train them so they go out to the field better prepared to help reduce the likelihood of a damage. It's so interesting to watch these different components of all of our solutions all starting to come together, because what you're really saying is use great data, make better decisions, and be able to handle it more effectively than you were yesterday. And that's what's so, I think, innovative in the way that Earth is approaching this challenge. Instead of just saying, hey, I can predict an incident, good luck. What we're saying is, there's an incident about to occur. Here are the steps that you can do to help you reduce the likelihood of that having that damage, which to me only then emphasizes the total value of a whole solution and not just using one component of it. And what makes it even better, as we talked about drift before, is once we start training our people to handle and reduce those damages, we probably won't have those damages. What we're doing is training our model to be better prepared for the new set of damages that comes through because we've already eliminated the ones that were obviously identified by using our model. What we're going to learn next is what are the common factors that are occurring with the incidents that are coming in now that we've changed our behavior. So I like it because one of the things that we can do is we have the data that we use to train our people with, and that just becomes another component that can be fed into the model to give us better results, to show better value, because this is a process, in my heart, I believe, that never ends. GIS has always been interesting because GIS is, I got a line in the ground here, don't dig there. And unless the line somehow moves tomorrow, I just need to know where it is to protect it. What I don't know are all the factors that happen above the ground. And so this is what makes risk and AI so powerful, is that it has the ability to kind of really change over time, but change in a way that's more beneficial based on your past history versus where you're trying to get to tomorrow. So I think this is a great spot. I'm incredibly excited about this platform. I think as we move forward, Earth will remain a leader in this because I think it's often overlooked. The commitment that we have made to AI and large language models and predictability has started in the early 2020s. While other people were just learning about ChatGPT and some of these things in the last year or so, we were doing analysis of data in I think 2020 is when we began this process, if I remember what Kyle said. So having that as kind of a backbone to start our process is really sets this product aside, but it sets this team aside because we're learning what data and how to make our data better. So I find the opportunity to do great things with AI is at an all-time high right here, and having the right staff, having the right people and the right partners is what's really going to take us to the next level. So I want to thank you guys for joining me today. You were great. This was absolutely a great podcast. I think there's a lot of value. If anybody listening to this has any questions, feel free to reach out to our contact information that's listed below. We'd love to give you some more information about what we're doing and how you can advance your goals of trying to get better by managing and leveraging your data. So thank you very much, and we look forward to seeing you on our next podcast.
All right. Thanks, Jason.
Thank you, Jason. Thanks, Zank. Appreciate it.